Welcome from my side. My name is Rainer Stropek and I'm very happy to be here. Let me start with a question to you. I ask this question to any audience I speak to, and typically I would say a few hands go up, and I hope today it will be different. How many people of you, who of you has already built some application based on Windows Azure? Wow. I asked the same question in an Azure training yesterday in Vienna, and I think out of 25 people, 2 hands came up. I'm really proud of Windows Azure. I'm using Windows Azure from the first day on. We went to the PDC, to the Professional Developer Conference, when Windows Azure was first announced. We went home, we ripped our original business plan. I was founding a company at that time. We ripped it into pieces, created something completely new, and started develop on the next day when we could get our hands on Windows Azure with Windows Azure. So we went live with our own software as a service offering, I think 4 or 5 days after Windows Azure going live. So we were one of the first companies in Europe really using this stuff. And today I'm going to talk to you about a topic that is very important for me, because, let me quickly introduce myself. I'm, yes, a developer, a speaker, a trainer, but in my main job I'm an entrepreneur. I'm founder of a company which is called Software Architects GmbH. We are located in Austria, in a small town named Leonding. It's near Linz. That's the 3rd largest city in Austria. And this company, Software Architects, our company, has created a software as a service offering which is called Time Cockpit. It's not that important what Time Cockpit does. I will not go into the very details, but it is a software as a service offering, and this is why I'm really the topic of software as a service in Windows Azure really touches my heart, because this is our baby that this team, my colleagues and me, have been working on for the last 3 or 4 years. And a lot of the things that I'm going to talk to you, and a lot of the things I'm going to present, come from my experience of building a software as a service offering on top of the cloud. A lot of the things that you will hear were at that time quite new in the community. We did some research projects. We also received some promotions from the Austrian government. We worked together with quite a few universities all across Austria and other countries too, to come up with the architecture that I'm going to talk about today. I would like to structure my talk today in 3 big topics. The first one, I would like to talk to you about why you should care. Why is software as a service important today? What changes? Which trends do I personally see on the market that make me think that software as a service is a good idea? The second one is about software as a service, and especially multi-tenancy. Who of you has heard the term multi-tenancy already? Nice, very good. So a lot of experienced cloud developers here in the audience. And the third one, I would like to propose some possible solutions for the problems that come up if you build a software as a service multi-tenant solution in the cloud. This is an architectural session. I personally am a developer. I have started developing, I don't know, 20 years ago, something like this. I started with C, C++ in the early days of Windows development, and I do a lot of .NET development. I'm a .NET developer. C# is my second native language, let's put it this way. So if you want, we can do a lot of walkthroughs and do a lot of discussions about .NET details, but to be honest, I would like to concentrate a lot on the architectural topics, and I'd love to make it an interactive session. So please interrupt me, please ask questions. I have heard that we have enough time. I have prepared a few slides that I'm going to talk about, but I'm absolutely happy if you have specific questions to go into other details or change the topic a little bit. So, why should you care? Why does end users care about software as a service? And I think this is the first very important message that I would like to tell you. Many companies today look at the cloud and they think about how will the cloud change my business? How will my business evolve if I go to the cloud? And I think this thought is not the correct way to approach the problem. The question is, how will software as a service change my business model? Because the cloud itself, well, you can use it to do your usual business. You can use the cloud as some kind of hosting provider. The thing that really turns everything, the classical ISV business, upside down is not the cloud, it's software as a service. I see the cloud as a tool. It's another tool that makes it easier to build multi-tenant software as a service solutions. The cloud is not changing, has not changed the way I work. The cloud has changed, let's say, the financing of my startup. Yes, that's true. But the cloud is in fact nothing else than a tool. Software as a service is the really strategic decision that companies have to think about. If you think about, let's say, a classical ISV that maybe did some projects with a few customers, a few large customers. So let's say we have a dev team, a new startup, and they were hired by this one large enterprise and they are building software for them, and they are thinking, hey, can't we create a product, a component of the shelf product out of this offering? And this is the situation that a lot of ISVs are currently sitting in. They started with this big idea with one customer or this customly developed solution, and they gave it a name and they put it out in the market, and they managed to get a few other customers. And they take, well, today they will not send DVDs or CDs to their customers. They put their installation programs on the internet, and all these customers, they have their data centers, they install this software, they paid for this software, and everything's fine. Maybe they have a maintenance contract, something like this. And such companies, such development teams, such ISV companies, their business is turned upside down if they decide to go for software as a service. The cloud comes later. Software as a service changes everything because they will not ship software, and even more important, they will not get upfront a lot of money. Some ideas here. If you are in this classical ISV business and you manage to get another huge customer, you will get a lot of money. You have maybe a salesperson, and you can pay this salesperson, again, a lot of money because you get a lot of licensing fees immediately, upfront. The customers have to be quite large because they have to be able to pay a lot of money for your licenses. If you change your business model and you go for a software as a service, I mean, think of things like Office 365 or so. But if you change your business model to software as a service, your customer, the entry barrier will be much lower for your customer. So maybe you can target, and this is what many people want, you can target a lot more customers, smaller customers maybe. But even the bigger customers, they will not pay you so much money up front. And this doesn't seem so difficult at the first glance, but if you think about it in more details, it changes, for instance, the whole way of financing your company. A lot of people say the cloud is an enabler for startup companies because you don't need so much money to build a data center to offer your service for your customers. Well, they are forgetting something. That's right for the cost part. But if you build software as a service on top of the cloud, well, that becomes tricky again because you will not earn a lot of money up front. Okay, the operational costs for your data center will be low because you use the cloud, but your revenue stream will be low at the beginning too. And a lot of other things come up that we are going to talk about. So this is the big difference of thinking in software as a service and thinking about the cloud. And we are going to talk about both things. First about software as a service, and then we are going to think about how the cloud in general and Windows Azure in particular can help us succeed in this software as a service business. I don't know if you have ever read either The Long Tail from Chris Anderson, the chief editor of the Wired magazine, or if you have read his book, Free. If you haven't, and you want to go into this software as a service area, I really recommend to read this. Why? Who knows the concept of the long tail? Only a few. The idea of the long tail means, in short, the following. If your software costs a certain amount of money, and you have a possible addressable market here in this area, you can only sell your software to the blue part of the market. Why? Because the yellow part of the market, they simply can't afford your software. If you want to sell a piece of software that costs, I don't know, 100,000 euros, only companies who have a budget of 100,000 euros can buy your software. It's as simple as that. And if you want to catch the long tail, the yellow market, you have to get the cost of providing your software down, and so you can address a larger market. Reducing the cost of software for your end customer means to raise your addressable market. That's the idea of the long tail. And if you think of, for instance, things like Exchange and SharePoint and Link and Windows Server and I don't know what. These things are expensive products if you run it in your own data center. If you buy it as a service, Microsoft Office 365, nearly everyone can afford this. And this is exactly the story of catching the long tail. Getting the cost of providing your software down, 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 down until you can address the entire market. And the most revolutionary approach is reducing the cost of providing your software down to zero. Because if you manage to get your cost of providing the software down to zero, really everyone can afford your software, everyone who owns a computer. And if you want to go that far, you should really read this book or listen to this book. There is an audio version too. You will get a lot of ideas how you can make a business of giving something away for free. In fact, it has always to do something with advertisements. When we thought about our own product, our own software as a service offering, Time Cockpit, we always said we don't want to be free. Because I personally am not a big fan of this ads-funded offerings like Facebook and things like that. I want to build something serious. Time Cockpit is something for the commercial market. Very small companies too. Our smallest approachable company, addressable market, consists of one person. And we wanted to build software that one single person can afford. And that also fits to, I don't know, teams of 50, 100, 150 employees also can work with. This was the problem, and catching the long tail means reducing the cost of providing the software. If you think of this, this looks nice. I think it's absolutely obvious. But if you want to change from this year to this year, you will hit a very important problem. And this problem, I call it one size does not fit all. If you build a certain kind of software, we can call it the SAP problem. If you build a software that fits perfectly for large or medium enterprises, and you bring the cost of providing this software down, you even give this software away for free, a lot of small companies are not interested in it. Why? Because it simply doesn't fit their needs. They don't need such complicated processes. They don't need, I don't know, 100 data fields in the master record of a customer in their CRM part of the software. They need something like this, and they get something like this. So if you want to catch the long tail, you will have a big problem. You have to be fit for this one, and you have to be fit for this one. You have to be extensible. You have to have, let's say, a small offering for the small customers, and you have to be able to build this big car for those who need it. So extensibility is a very important thing if you go for software as a service and you want to catch the long tail. If you build software just for very small companies, it's simple because you can build exactly that car. If you build software just for the large ones, you can build exactly this car. If you want to offer a solution to both, you have to be customizable and extensible. And this brings a lot of complexity to the table. Story from the real world. We try to bridge the gaps between both. We try to have an offer for a company or a team with one person, and we try to have an offer for a company or a team with, let's say, 150 person. And this is giving us a hard time, because it's not only that the software has to be extensible and customizable, it's also a question of marketing. There are, for instance, competitor of ourselves. We're a time tracking solution for knowledge workers, for people who sell their time. That's what Time Cockpit is all about. And we have competitors on the market who only have a fraction of the functionality that we have. They can't really do anything. I mean, we are just laughing about their features, but we didn't laugh very long because they had a very targeted marketing for this kind of users, and they are kicking our ass when it comes to small customers. It's really hard, if you want to catch the long tail, to have not only a product ready for both sides, a software as a service solution ready for both sides, but it's really hard to build up marketing that is nice for large and nice for small teams. And I think the marketing concept, again, has to be different. This is a, I think, interesting publication. You see the source, the reference down here. It's called the Software as a Service Configuration Competency Model. It's directly related to the previous slide. It's about how extensible, how customizable your solution is, your software as a service offering is. It starts from entry, which means well-designed functionality, standardized, and you want to cover a very specific niche in the market. Then it goes up through aware, capable, mature, up to world-class. I would say world-class, these are the IDEs of the world. These are the Microsofts, the SAPs of the world. The entries, that are those companies that I was just telling you about. They build a very focused solution. They offer you, I don't know, 5 data fields for a customer record in their CRM system, and if you need a 6th field, well, use another solution. It's as simply as that. And we wanted to go, when we built Time Cockpit and designed Time Cockpit, we always wanted to go for this mature market. We are not Microsoft, we cannot afford a world-class configuration competency model. But mature, what means scripting-based programming, very flexible customizations, these are the things that we wanted to offer. We wanted to build a software as a service solution that can be adapted, tailored to the specific needs of the customers. And it doesn't matter if it is a single person or a 150-person team. So, now we know what software as a service means, and we know what catching the long tail means. These were the business part of the talk. So now let's bring this multi-tenancy thing on the table. What kind of additional complexity do we have if we want to build software as a service, if we want to be extensible and customizable, and if we want to be multi-tenant aware? Again, a nice publication. It's also available on MSDN because Microsoft, the authors are or have been employees from Microsoft. I'm not sure if they are still. But let's take a look at it. It's called the Software as a Service Maturity Levels. There are 4 Software as a Service maturity levels. The first one, I've been in this business for many years. Before I founded Software Architects together with my colleague Karen Huber, I have been founding 3 other companies, all working in the area of Microsoft custom software development. So what we did, we had some customer, we built some custom solutions for them, and we had another customer, and we built another solution, and maybe, when we were lucky, we had a 3rd customer, and we could reuse something from here to here. So we used clipboard inheritance, copy-paste from instance 2 to instance 3 and offer a certain piece of software. Can I run this stuff, software as a service maturity level 1 in the cloud? Of course I can. Is the cloud useful in this area? Of course it is. Very useful. But I just use the cloud as a kind of, let's say, hosting on steroids. But this is not the kind of multi-tenancy and software as a service that I'm now talking about. Of course, a lot of the current ISVs in the Microsoft space, when they offer component of the shelf software, they are on the software as a service maturity level 2. They build some kind of component of the shelf software and they ship it to every single customer and they install it in their data center. Or they install it in the cloud. In fact, we don't care. I know a lot of very successful ISVs. They use the cloud, but they use it in exactly this way. Every customer has its own subscription. One is running it in Amazon, one is running it in Azure, and one is running it in a local kind of cloud because they are afraid of the Patriot Act or something like this. It becomes interesting for me when we're talking about software as a service maturity level 3. Software as a service maturity level 3 means that we are serving multiple tenants from a single instance. Let's say a single web server, for instance. But of course, we are going to hit some kind of performance issues if we don't have 3 tenants, but if we have 1,000 tenants, then it's becoming interesting because then we are on software as a service maturity level 4, and there we have this kind of elastic infrastructure down there with a load balancer in the middle and a lot of tenants up there. When we decided to go for software as a service in the cloud, we decided to go for software as a service maturity level 4. And this changes a lot. And if you take a look at this very simple architecture diagram, I mean, this is where Windows Azure really shines. Windows Azure has been built from the first day on for these kind of infrastructures. Other competitors like Amazon, their original intent was something like this, or maybe a little bit this, but they originally have not been built for this stuff. Yes, today you can use them for these infrastructures too, but Microsoft has a lot of advantages in this area. And so for the rest of the talk, I'm going to talk about multi-tenant, software as a service, configuration competency model mature, and software as a service maturity level 4. So this combination, this is what I'm really interested in and what I'm going to talk about.
Your slides are going to be available?
Of course, if you want them, you can have them, no problem. Again, to make one point absolutely clear, the cloud doesn't mean multi-tenancy from the standpoint of the end customer. It's simple. If you are today already in the ISV business and your application is not multi-tenancy, you still can use the cloud, because if you can even make it software as a service, you can build a portal, and if you get a new customer, the customer says, hey, I want this software, and you can on the fly provision some web servers, create some database clusters, set them up, and give the end user access to his personal environment. The end customer will not even recognize that your software is not multi-tenancy. It's software as a service. Everything's fine. And if the next customer will come, fine. Do the same thing. Create a separate server, a separate set of databases, or table storage, or block storage, or whatever you want to create on the fly. Microsoft is offering you all the things that you need. PowerShell scripts, web services for setting up this environment, and you are in the cloud, you are software as a service, but you are not multi-tenancy. Maybe some customers will say, well, yes, it's fine, I want to go to the cloud too, but I want to have very close control about the infrastructure, so I want to own the subscription with Microsoft. For instance, this is something what we are offering our customers. If they are allowed to, let's say, bring your own database, they can tell us, it's fine, we want to live in your multi-tenancy world, but you know what? we tell you the connection string to the SQL Azure database where you store our data in, because we want to have control over this database, and if we don't like you anymore, we want to be able to change the password and you are off. So this is something that we offer them, and you can do exactly the same. If you want to be software as a service and you're not multi-tenant, well, fine. This gives a lot of, let's say, a good feeling to some customers. It gives a feeling of control to them. But again, this is not the multi-tenancy thing we are talking about. The multi-tenancy thing that we are talking about is this kind of infrastructure. You're getting your first customer. And when you're getting your first customer, you have your first server and you have your first database cluster. Or when I say database, I'm really a database guy. You know, the kind of the applications that we build are complex, business-oriented applications. Okay, so we are not into that NoSQL thing because there is a big problem with NoSQL, and this problem is NoSQL. We love SQL, we live with SQL, and therefore when I say SQL, please in your mind you can exchange it if SQL is not relevant for you with table storage, blob storage, or whatever storage technology you like. But as I said, I'm a database guy, so I have a database server here, and when I get new tenants here, I can elastically grow the servers and the databases, and I will serve the different tenants. These are not users, they are tenants from the same infrastructure. It is a shared infrastructure. And when I get even more customers, maybe I only add another database server because my web servers are not busy enough. But now it's getting interesting, because the important thing is if I lose customers, tenants, or if the tenants are currently not active because it's night and nobody cares for time tracking during night, for instance, then it's very interesting if I can scale down my infrastructure. And this is what the cloud has been built for, and this is where multi-tenancy shines. I always bring this picture for this kind of slide. Imagine you're going to buy a television set tomorrow. I think you are going to take a look at the technical specification and you're going to think, well, how much electricity will this television set need? It's the same for your customers. If they buy your software, they will think about, well, how much do I have to spend for my servers? How much resources do I need? But I think in the future, your customers, and more important, you, will ask yourself another question. How much electricity will this television set need if I'm not watching television because it's on standby? How much does your software cost you, or your company's website cost you, if nobody is taking a look at it? That's an important question. It's maybe not an important question if you just have 3 customers and you can easily live with low costs, low-priced web server and a single database server. But if you have a few hundreds or thousands or 10,000s of users, this question becomes very important, because you will not be able to afford it to have, I don't know, 100 web servers always on, always available if nobody is currently using them. Remember the first few slides that I've shown you. Catching the long tail means what? Reducing the price for offering your solutions to your end customers. How can you reduce the price? By reducing your costs. How can you reduce your costs? By perfectly managing this kind of infrastructure. If I go back a few slides, here, this one. Why is that not as good as the next slide? Because every tenant has at least, if we're talking about Windows Azure, 2 database servers. Okay, now in a few weeks, months, years, I don't know when we will have Windows Azure websites, and there it's going to be a little bit different. But currently, if we are talking about the things that are currently in production, we need at least 2 web servers for a web farm. We need at least 1 database cluster at this area, and every tenant needs this infrastructure. And if this tenant, this here, is currently not using the app, and this one needs a lot of power, this tenant cannot use this server, and we can also not turn it off because, well, it's there. There is a minimum cost. Okay. This is the question that I have to. This brings us to a very important sentence. Optimization is sexy again. Today, a lot of ISVs that sell software not in a multi-tenant way, they don't care. They simply don't care about optimization. Because why? If the software is too slow, then you tell the customer, buy a stronger hardware, buy a stronger server. The cloud changes a lot here. As you all know, because you are experienced in the cloud you always have variable costs. If you don't need the server and you turn it off, you don't pay for it. If you buy the server and put it in your own data center, you have to pay for it always, no matter if it's doing something or not. But you know what I'm seeing in the cloud? For Windows Azure, for Amazon, for nearly all my customers and clients and partners, they don't really use this variable cost thing in the cloud. Most customers that I know, they go into the cloud, they buy an extra large VM, install their software on it, and they keep with the extra large VM, and they don't give a shit about the CPU utilization of this extra large VM. They haven't stopped thinking in the same way that they thought when they had their own data centers. When they had their own data centers, it went like this, okay? We need another application, and if we need another application, we need a database server, and if we need a database server, we immediately buy a huge machine. So we have to go through this budgeting process, and it's hard to get money, and you know what? It's not harder to get 20,000 euro than getting 10,000 euros, so let's go for the 20,000 euros so we get it. No one in most companies is interested in the utilization of this 20,000 euro database server. The exact opposite is the case. The next team that is installing another application is not reusing the big box. No, they have bad experiences with sharing machines, so you know what, let's buy another server, let's get another 20,000 euro budget. This is the kind of thinking, and I think we have to change that. If you want to go for software as a service, you are the provider. The costs are on your side, and if you want to catch the long tail, you have to optimize, because optimizing brings your costs down. This year, I did a talk at Tech at America and Tech at Europe about the IT professional's role in a world of software as a service. And you know what? This thing, optimization, is a very important thing for IT professionals in your company or yourself if you are an IT professional. Because in the past you were responsible for installing service packs. Now you can directly influence your company's margins, your company's business by optimizing your elastic infrastructure, your shared infrastructure. If you optimize it better, you reduce costs. If you reduce costs, you don't only grow the margin, but you grow the addressable market because of the idea of catching the long tail. And this has a huge impact on your business if everyone in the company understands software as a service and multi-tenancy. From an overall standpoint, everyone wins, because the customer will get the software at a lower price. Because with the shared model, they are living in a shared world, and when they need a lot of power, they get a lot of power. And if they don't need a lot of power, they don't pay for it. That's an important thing. But, there is a big but here. What I've drawn here is a curve that should visualize the development costs. The development costs go up here, and the operational costs per RGU. RGU stands for revenue generating unit. That's a very important term when you go into the software as a service market. Revenue generating unit means, for instance, the user. For Time Cockpit, we, for instance, charge 20 euro cent per user per day. That's the revenue generating unit. 20 euro cent per user per day. If you buy, I don't know, Office 365, then you pay per user per month. But you could think of other business models. You could think of a business model where you pay per transaction, or think of blob storage, there you pay per 10,000 transactions. This is meant by revenue generating unit. And the thing is, if you want to optimize to get the cost, the operational costs per revenue generating unit down, what you will have is more and more development costs, of course, because optimizing isn't only sexy, it also takes a lot of time. It takes skilled developers, and it takes some effort to, for instance, let's make it more technical, to implement a really good auto-scaling scenario for your web servers, for your cool new web application, for instance. And this is a very important thing, because if you want this highly optimized solution, you have to be very sure that you will be able to catch the long tail. If you spend hundreds of person days optimizing your multi-tenant infrastructure, and at the end you are not going to succeed on the market because your marketing is poor, or you misunderstood the market completely, for instance, you spent a lot of money. So if you want to go for many small customers, you will probably need a highly optimized solution if you want to catch the long tail. But if you say, you know what, I will only target a few large customers, and for them it doesn't matter if my service costs 100 euro per month or 1,000 euro per month. If they want it, they're going to buy it. That's fine. The problem with this curve is that it's not really a technical solution. And it's very hard to decide, I will start here and gradually move down here when customers get on board more and more. It's really a strategic decision. And a lot of people, as I said, say, hey, you know what, the cloud is heaven for startups, for instance. Well, kind of. Yes, that's true. But they forget that the largest part of investment that you have to do when you start a new software as a service business is not building a data center. It's developing the solution. Paying the people developing the solution. Especially for us, as we do the development work here in a high labor country and in the European Union. It might be different in other parts of the world, but in our part of the world, it's really the big investment. And there is one very important term here that says design to cost. Have you ever heard from IKEA the famous saying that says, we design the price tag first? They don't build this chair and then they think about how much can we take for this chair, how much money. They first design the price tag. They say, we need a chair and we think that our customers are willing to pay 20 euros. And then they design the chair, not in the other way around. And this is exactly what I mean. This is the difficult thing. This is where entrepreneurship comes in. This is where founding a company becomes really interesting in the area of software as a service, because you have to decide if you want to go this way or if you want to go this way. And your venture capitalists that will give you money will ask you exactly that questions. What is the market that you are going for? This way or that way? And this influences everything. Your balance sheets, your planning, your financial planning and things like that. And think of the following. Imagine you say, I'm going to build this cool solution and we want to make it as cheap as possible, as affordable as possible, so that we get 100 million users out there. Here. It's easy to say that, but you have to somehow finance this stuff. And you have to have the developers who optimize your solutions. And if you go for software as a service, you will not have a huge revenue stream at the beginning. It will build up slowly. So you will have huge upfront costs for development, and you will have slowly building up revenue because your service is cheap. Understand what I mean? So this is where the business part comes in when we are talking about software as a service and catching the long tail. Now let's get a little bit more technical. When we go for multi-tenancy and we have a shared infrastructure, then a technical topic comes up that we have to deal with, and that is tenant separation. Imagine you have tenant 1 and you have this shared infrastructure. Can be some kind of web application, web services layer, I don't know, some kind of shared infrastructure. If tenant 1 accesses his data, again, I'm a database guy, but replace this stuff by any kind of data store that you have in your solution, and tenant 2 accesses his database somehow through some data processing, and he will get to his data, and that's it. The worst thing that could happen is this one, is cross-tenant access. If you, for instance, our good friend SQL injection, it's really poor. It's really a catastrophe in a single tenant world, because then employee A can see the salary of employee B. Wow. Not good thing. But in this area, it's even worse, because you are in a shared infrastructure. And not only employee 1 can access data from employee 2, but tenant 2 can access data from tenant 1. And then it's really becoming tricky. And if you go for software as a service, there is one big asset that you have if you go for software as a service, multi-tenancy in the cloud. And this asset is trust. If you lose the trust of your customers because something like this happens only one time, and this stuff is standing in the newspaper, you can close your company. You're done. It's over. And you don't want that. Sometimes it's getting tricky, because sometimes you don't have this very simple approach where you say, okay, I have, I don't know, some kind of processing logic, and then I'm using Entity Framework to do some queries in the database. That's simple, but it's in your architecture, real-world architecture, it's getting much more complex, because maybe you have some kind of caching mechanism here in the middle, or you're using this nice little, I don't know, service bus things from Windows Azure, I don't know what. And you have to be always aware of the fact that you have tenants in your system and that you have to separate them. And my experience, I'm doing a lot of coaching for companies who want to start a business in a multi-tenant software as a service world. And my experience is that it's hard to impossible. Hard or sometimes impossible to get a software that has been designed for a single tenant use to a multi-tenant world. In many cases, we calculated the project, and it was more cost efficient to throw everything away and design from scratch than bringing the context of a tenant into a software that is not aware of tenants, that has not been aware of tenants when it was originally created. Okay, let's talk a little bit about this elastic infrastructure, but I think I can, typically I talk a lot about this slide, but I think in this audience I can make it really, really short, because you know this idea, you have this expected load, and if you build your own data center, you have to, bless you, you have to invest in your own servers, and the resources go up, and the real load is sometimes higher than what you have and sometimes lower than what you need, and therefore you spend too much money. And in the cloud we think we want to go this way. Yes, we all know this story, right? Okay? Yeah. What are the important things? First one, I'm sure you all know that, in the cloud is not like electricity. I'm very sorry, I'm quite sure that you have already seen that. In the cloud, it's like a hotel, especially in Windows Azure. In the hotel, I've booked a hotel from today to tomorrow. If we are going to have a party for the whole night, and if I will not show up at the hotel, I will have to pay for this room. This is what Windows Azure is all about. It's not about electricity. You have to pay for your servers, even if you don't use them. So, server usage is a very important factor in a multi-tenant infrastructure. It's not only how many servers do I have. The question is, how good do I utilize them? And that's really hard, because you can only add a new server, and you can put these servers away, but of course your application has to be aware of a changing infrastructure. But the question is, how do we scale? How can we optimize that? And then it's getting tricky. Oops, there's something with the animation here. This one, I wanted to say that if a lot of people forget that when they buy software in an on-premise data center, it's not only about the hardware costs, it's also about the software costs. And if you think about, if you're in your company and maybe your boss is not fully convinced about Windows Azure, for instance, always emphasize that with Windows Azure you do not only get the hardware part, but you also get the software part. If you, I don't know what, take a large VM and put a SQL server on top of it and do some calculations and you get rid of it, you do not only get rid of the hardware costs, but you also get rid of the licensing costs. And licenses, if you buy licenses, then you have the costs, you have the capital expenses, and in Windows Azure you have operational expenses, not only for hardware but also for software. That's an important point and a lot of people forget about it. Okay, how can we scale? If we think about technologies, how can we scale? Well, in Windows Azure you can scale through the website. I'm quite sure every one of you knows, but the nice thing is that you have, for instance, PowerShell scripts. You get these examples, and I'm sure a lot of you already know this, and I'm sure you have great talks about topics like that. It's only 2 lines of PowerShell scripts, for instance, to scale up or scale down a cloud service. It's really simple. And with Windows Azure websites, it becomes even more powerful. Who of you has already used Windows Azure websites? Half, approximately. Windows Azure websites is great because the minimum amount of money that you have to spend to use Windows Azure websites is much lower than cloud services. Do you see the pattern? What is Microsoft doing? They are catching the long tail. They are bringing down the operational costs per revenue generating unit. Because today, if you want to run something with a cloud service, you have to buy at least 2 small roles, small compute roles. How much is that? 120 euros something per month, 140, depending if you have an enterprise agreement or something like this, something in this area. And for Windows Azure websites, you can seamlessly scale down to zero costs. It's free. And if you need it, you scale up to 3 extra large boxes, each having 8 processor cores and 14 GB of RAM, for instance. If you need that during 2 hours per day, you can have it during 2 hours per day, and then you can scale down to 0 costs. Microsoft is catching the long tail, and we should use these scalability mechanisms. For instance, in our own company, of course, we run everything with platform as a service. So our entire infrastructure is based on cloud services. You know what we did over the course of the last weeks, months, let's say? We changed our website from cloud services to Windows Azure websites. We changed our web services from running in cloud services to Windows Azure websites. Why? Because we can optimize better. We can scale down to nearly 0 costs during night because we don't need it. And there are other important issues here too that I will come to later on. So scalability with PowerShell, with web services, through websites, you can use it. It's getting much more complicated if you want to do auto-scaling. If you want to do auto-scaling, unfortunately, Windows Azure doesn't provide a service out of the box where you could just say, hey, you know what, if the processor is above 90% utilization on average on the last hour or so, then add another role. It would be nice to have something like this, but that's too simple. That's in reality, that's much too simple. Because there is a new kind of, I mean, I haven't experienced that, but I've read about it. There is a new kind of attack approaching with this auto-scaling stuff. It's a so-called economic denial of service attack. That means some guys who are not that good with you, they send you traffic and you will scale up. And if you scale up, your costs will go up and you will not have your revenues going up. So you have to be prepared in your auto-scaling mechanism or scenarios that you only scale up if the traffic generates revenue. Then it's fine to scale up. But you should not scale up if your traffic does not generate revenue, for instance. Then you have to do something else. And it's really hard to do that automatically. That's my experience. We do not do auto-scaling. It would be much too expensive for us to come up with a good strategy. Not a single one of my partners or customers or companies that I'm a coach for does auto-scaling. Most of them, they do scheduled scaling. They know some typical days or hours where their customers are really, really heavily using their service, and they're scaling up before this time and they're scaling down after this time. And a lot of them, we have the same thing, have some kind of alerting mechanism. If, I don't know, TechCrunch is featuring your software as a service business on the headline of today, you want your website to respond. Because you will only get a TechCrunch TechCrunch message one time in your life, and then your website shouldn't be down. Okay, so in this case, you have this typical boost of access to your service that you weren't aware of before. And in this area, you need some kind of alerting mechanism. I'm going to talk about this in a moment.
Did it happen? Did it happen?
Well, we didn't get a message on TechCrunch, but we did get a message on the largest tech website in Austria. But they know that that's a problem with startups. So again, they phoned us and they told us we will publish this website in the next hour. So we had the time to scale up our websites, and we knew when we could scale down again. But we were very, very happy that we had the possibility to scale up, so that we have designed our service to be elastic and multi-tenant, and we were able to cope with this load. That was not. From my point of view, it's very important to have a powerful management API or tool present if you want to go with this multi-tenancy software as a service. You could, of course, use things like Azure Diagnostics and build your own dashboards. You could use like System Center Operations Manager. I'm not a SCOM guy at all, so I know just the name of this stuff, but I've never used it. What, for instance, we use a third-party tool from CompuWare. It is an Austrian company that was acquired by CompuWare a few years ago. I know it's called Dynatrace. And the beauty of Dynatrace, and you should build the same with Azure Diagnostics if you build something like this, is that it's tenant aware and it's elastic server infrastructure aware. What that means is it always gives you a picture, a historical picture or a current picture, it depends on you, about your entire infrastructure, all your tiers in your infrastructure, from the end user's browser to the web server, maybe to some kind of, let's say, web services infrastructure, and then in the back end, for instance, the database server, and it gives you exact numbers over the whole infrastructure picture. And it helps us a lot to see, for instance, the latencies, the number of requests per tier, and when you have to scale up and scale down. And the beauty of third-party tools like Dynatrace is that you don't have to write a single line of code for that. You just install a small agent on your box, and everything else is done for you. You get these beautiful pictures out of the box. But even more important for us is that we made this stuff tenant aware. So we have an end-to-end response time from the user's browser, from the request, to the answer of our application, and through the whole stack. So what we can ask questions like, if we have a service level agreement with a certain tenant that only X% of the requests take longer than, you know what, in this case, we can really take a look at a certain visit. We see the service level agreement, and we see exactly how much time our the entire request took. And if we have a certain request, in this case, for instance, we have a certain request, maybe this request the customer wasn't happy, then we can break it down, and tools like Dynatrace, they are doing similar things than .NET profilers in production code. So they are gathering, they are instrumenting the .NET code, and I can, like in CSI, take a single request from a certain tenant and break it down to every single .NET method. I see in production, I see how much time was spent in which methods, how much time was spent for I/O as compared to CPU, for instance. I can take a look at every single database query, how long it took in the database server. I see on which server was this executed, and I see every single exception that happened during the call. And with this is the kind of alerting that I mean. So I see the resources per server, I can break it down by tenant, I can take a look at the service level agreements, and I can even go down and analyze in more details what was the root cause of the problem that this certain tenant is so slow, for instance. And the same works for database, for instance, too. We have a certain limit, you see, a fair use policy per tenant. This is just a demo site for us, a certain fair use policy, and if a certain customer tenant goes above this fair use policy, we can take action or not. We can decide then from time to time. This doesn't look very nice, but you have to imagine a pie chart like this. What tools like Dynatrace, for instance, make possible, we don't use it, but I know companies who think about using it for that. It makes it possible to have the revenue generated units defined as CPU cycles. Because with a tool like Dynatrace, the Dynatrace tool knows the concept of the tenant, and you can create reports that tell you how much CPU cycles were spent per request that can be assigned to a certain tenant in your shared infrastructure. And then it's getting very interesting. This can be used for, again, checking fair use policies. It can be used to detect fraud, or it can even drive your revenue by charging the user, well, exactly what he or she used. You know what I mean? And I mean, this makes it perfectly clear why utilizing the infrastructure that you have in the cloud really makes sense. Because, again, I repeat myself, you bring your costs down and you're catching the long tail. Our biggest learning, my personal biggest learning, was automation is key. My personal background is in IT consulting. And my colleagues came to me and they were telling me things like, hey, we need to have a build server for automated build. And we need to automate everything in the build process. And we need to automate the entire deployment process to Windows Azure. The build server has to upload the cloud service packages and spin up the machines, and everything has to be automated because it's so cool to automate. I was very skeptic at the beginning. I was really very, very skeptic. Because I told them, hey, you know what? We need to develop and we need to deliver value to our end customers. We need to develop new features. We need to develop new modules. We should spend our time on developing value for the end customer, not automating things that take, I don't know, 10 minutes for someone to do by hand. But we really changed the way we work. We did the automation and it paid off. In a world of multi-tenancy, I completely forgot at the beginning that being scalable does not only mean scalable from a machine and web server and database stuff. Being scalable in a software as a service world means also being scalable from an organizational standpoint. How many, I don't know, assistants do you need to handle your monthly invoices for 10,000 customers? Do you write them by hand, or do you automate the entire process? Okay, building the automation, paying someone to automate this stuff is a lot of upfront revenue, but you need this level of automation, otherwise you are not ready for the long tail. And we have, again, the same thing. It's not only a technical automation, it's also an organizational automation that you have to think of. And I want to tell you a story here. I was coach for quite a large vendor, hardware and software vendor. I'm absolutely sure everyone in this room owns some kind of device from this vendor. I'm not allowed to mention it, but it's a large one. No, it's not. And we were thinking about whether we should offer a certain piece of software for a specific piece of hardware they are selling as a service. And they were saying, yeah, perfectly, you want to this, catching the long tail, everything's fine. And then, yeah, architecture, everything's fine, Windows Azure, of course, enterprise agreement, thumbs up, software development, works great. And then we were thinking about, well, how are we going to do billing? And I told them, you're a worldwide enterprise, billing shouldn't be a problem for you. And they said, yeah, we can write bills in every country of this world. But internally, we know that every single bill costs us 100 euro. It doesn't matter if we bill 5 euro to the end customer or 50,000 euro to the end customer. Handling this invoice means costs of approximately 100 euro. And you know what? We found out that this company has outsourced the entire invoicing process to a third-party company, and it was not theoretical costs of 100 euro. They really had to pay 100 euro for every invoice that they sent out to the end customers. You know what that means? It was cheaper to give away the entire software as a service solutions to all customers than sending them an invoice, because of the costs of sending them an invoice. And this is what I mean with automation is king. If you go for catching the long tail, if your boss is telling you, hey, we have to catch the long tail, I've read this cool article from Chris Anderson, think about this. You have to find a solution for that. The nice thing is that in the world that we live in today, you find services in the cloud for nearly all of these processes. Yes, there are software as a service vendors who do invoicing for you at a very low price. Okay. Next big topic. Again, if you have questions, ask me, interrupt. Extensibility. It's getting more technical now. This is one of my favorite topics. Please stop me if I'm going too much into details. I love talking about this. Extensibility means for me writing a program where someone can change the behavior of this program without me changing the code for it. And the first thing that we had in our mind when we designed our own solution, and a lot of people that do similar things think this way, is that if you want to build a component of the shelf, software as a service solution that is extensible and customizable, I told you why you need that, means that you are not really developing the final solution. You are only implementing some kind of bits, some kind of a meta model. This is what you are building, and someone else, maybe a partner, maybe your customer consulting team, or maybe power users at the end user part, they are putting these things together to really make it something useful. Similar to, I'm quite sure everyone knows SharePoint. SharePoint itself, unfortunately, yeah. SharePoint offers a lot of things, but these things are not really connected. If you want SharePoint to do something useful, you have to build something out of these things. And it was the same for us. When we started with our own software, Time Cockpit, we were thinking about which pieces do we need so that everyone, our partners for instance, our vertical partners who want to, I don't know, install our application not at a software development shop, but at a, I don't know, at a team of CAD designers anywhere. They need a little bit different things. So we are thinking about this meta model, and it even becomes worse. Some power users at the end user side, they want to change it also. So the important message here that it's not enough, this is our experience, it's not enough to build a C# solution and add MEF to it, so Managed Extensibility Framework, and tell the end customer, you really want to change this form, you need an additional field in this form, no problem. Start your Visual Studio, write some nice lines of XAML code, and then build an MVVM backend to it, and then drop this stuff, no, sign it and strong name it, and then upload this stuff into the GAC, and then we're picking it up for that, and you have an additional form. That doesn't work, because there are different kinds of skill sets that you have for different tasks here. So when we decided our service, and again, we didn't invent this. If you take a look at, for instance, Microsoft CRM, they are doing exactly the same. Here, these guys, they know Visual Studio. Here you need the MEF part. These guys, they don't know Visual Studio. Maybe they don't start to cry when they see a menu item that is called debug, you know? But these guys here, they immediately turn off the computer and go home if you add them a menu item that says debug. Yeah? So there are different levels of uses, and when you design your service for extensibility, you have to think about what are the skills of these users. You don't only have the developers and the end users, but there are a lot of people sitting in the middle. And if you want to catch the long tail, if you want to build a software here in Belgium, and you want to catch the long tail, so I don't know, the Brazilian people will use your software, it's very likely, if you don't build a trivial application, that you need some kinds of partners who have the possibility to customize your solution to the needs of the Brazilian market, for instance. And you have to think of, before you design your architecture of your solution, what knowledge do these partners have? Are they able to write C# code, or are they script kiddies? So we have to give them something else. So this is a very important decision that you have to make when you think about customization. Next one. If you think about customization, you have to make your, whatever this API here means for you, your API has to be part of the product. And this again changes a lot of the development processes. I mean, take a look at Microsoft and do it the same way. This is something that Microsoft does great. They have their development teams, and these development teams build APIs. These development teams build the documentation, and then you have separate guys using this API, and they are publishing this API to us all so that we can do exactly the same. What they do, build some kind of automation processes, UIs on top of it. And this kind of thinking, this is what you have to implement in your development team. You have to have some kind of, I don't know, backend developers, and then you have this UI, front-end process, I don't know what developers, and let them, the best thing would be, if you are large enough, put one team in one country and put the other team in the other country, and they are only allowed to talk to each other via documentation. And the documentation, you ship it with your product. And then you really have a good API. That's really a nice thing. Then you're going to think about, I mean, we learned so much here, and it's easy to say, but it's hard to do. Just as, again, a story, what we, for instance, do, we do not only sell our Time Cockpit, but we license the technology behind Time Cockpit to other ISVs. In our own world, yes, we have a very clear separation between, for instance, the data access layer and the UI part. But it happened that sometime in the past, someone added a internals visible to attribute in the data layer to the UI DLLs. Does the C# developers know what I mean? You know what this means? You don't have to think that closely for every single method, whether you make it public or internal, because the UI can access internal methods too. But if you give away your data layer as an API, as a part of your product, your customers will not be internal visible too. And then things become tricky. Yeah. So just one example why this isn't so simple. Internally, sure, we can. When you build for extensibility and you want to make your API a part of the product, then writing specifications becomes quite tricky. Because typically in a specification, you start with the UI. You hire some nice designers, we did that too, that who draw really nice pictures, and these pictures maybe you convert them, as I do typically, in some kind of PowerPoint presentation where you can, PowerPoint for me it's the best UI design tool that I know, because I'm capable of handling it, and I can simulate even things like drag and drop and animations and things like that. I know there are more powerful tools on the market, but I love PowerPoint for that. And then you develop some kind of prototypes, and sometimes in the future you have your end product. We know how that works. You can go out to end customers and ask them how should the UI look like. You can go out to end customers and ask them, do you like our prototype? Do you find it nice? Do you enjoy working with this prototype? But how do you specify an API? How do you write a specification for an API? Most people don't do it at all. They have this one, and they have read about MVVM, and they sit down and they start developing. And then you have nice class libraries, and they are simply not usable and understandable for anyone who wants to use not your UI, but your API. Does your API have a user interface question mark? Yes, because developers are human beings. They are users too. And what is the user interface of your API? Good. Well, class names, method names, exception names, things like that. Thinking about if it's really a good idea to call the message, do something, and return a Boolean. There is a naming convention of that says, call this method, try do something if it returns a Boolean, and this Boolean indicates the success of this method. Just one important thing. So what we, for instance, do in this area, if you want to go for extensibility, this is here the point. If you want to go for extensibility, then write specifications or documents like that. This is not a documentation. This has been written before the API was, before a single line of code was developed for this API. It's not test-driven development, it's scenario-driven development. I'm thinking about what will the UI developer, what will the partner who customized my solution to the Brazilian market, what kind of tasks will these guys have to perform with my API? And then I'm really writing down some pseudocode or JavaScript code or Python code or C# something like code, and I try to feel how it will, how the end user, the user who will consume my API, will feel when performing the tasks that I'm thinking that he will perform. How will he feel? And in our case, in this case, it was a .NET API, but in your case it could be a web API. If you build a web service that sits between your JavaScript-based Windows Store app and your multi-tenant cloud app in the background, and you want to open up your web service API to the public so that others can do some kind of processing on top, then you have to write some specifications like that, because you have a user interface, and this user interface is your web API, or your .NET API, or your, I don't know, Node.js module that you write, or whatever. Extensibility from an API standpoint is, from my point of view, not enough if you go for extensibility and multi-tenancy. In this area, you will change your mind to metadata. You're not going to program, let's put it the other way. In the Software as a Service Maturity Model 1, you write different C# code for different tenants. In 3, you write a single piece of code for a lot of tenants. Well, it's the same as for 2. You write here some kind of code for all tenants, and everyone is installing it. But the very big difference between here to here is that in this case you can, for instance, store some kind of configuration infrastructure in, let's say, a web.config file. Why? Because there is a different web.config file for each tenant, because every tenant has its own server, for instance. In this area, this simply doesn't work. You need to store metadata configuration infrastructure differently. You have to store it in some kind of tenant data store. We store it in the database, but you can also store it in some kind of table store or block storage. So let's go into more details, and I'll tell you about my ideas in this area and what we did and what worked out well. First thing, one decision that we made, and I'm not sure if I can recommend you doing that, is we decided that our data model is not fixed. Some companies do that. Examples, SAP, MS CRM, SharePoint, and a lot of other companies do that too. Accept the vision. They all come with a flexible data model where the end customer can add tables, they can add fields, they can do things like that. We decided we want to have that too. Can you remember the extensibility models, capability models that I've shown you at the beginning? I told you that we decided to go for the mature model. So that means large customizable data model and things like that. So in our case, we did it this way. We created a domain-specific model. What does domain-specific mean? We thought about scenario-driven development, which kind of data type and typical data structures our end customers will need. For instance, in our business, it is typical that end users have time-dependent values. So time-dependent value could be the costs per employee. This year is, I don't know, 30 euro, and next year it will be 35 euro. Or the hourly rate. It's not a fixed hourly rate for every customer, for every employee, but it could be an hourly rate for a specific project, and there for January we have a high hourly rate, and for February we have a lower hourly rate, for instance. So this is a typical domain-specific model. We came up with this scenario, can you remember the scenario-driven development? And said, hey, we have to make it super simple for a customer to add a time-dependent value to the underlying database. Does SQL Server provide that? Nope. Does table storage provide that out of logs? Nope. They can't do it. You cannot say create time-dependent value. There are database systems on the market that are able to offer that out of the box, but SQL Server can't. So these are the kinds of domain-specific data types that we have thought of, and we let the user change this model by simply changing this domain-specific data model, and then we take this data model and create, where is the arrow here? Do you see this black arrow? I have not seen it. Now it's coming up. We take this domain-specific model, and from this domain-specific model we create a tenant-specific database, and this tenant-specific database can be different from tenant to tenant. Remember what we have. We have a shared infrastructure, and every single tenant has a different looking database schema, for instance. This has a lot of consequences when you go to the cloud and when you design your infrastructure. We store that domain-specific model inside of the tenant database, and then we create a kind of data access layer that knows this metadata and, for instance, knows how to handle time-specific data, or knows how to handle graph data structures, or knows how to handle validation rules that can be different from tenant to tenant. here comes something important into it. When we designed our application, and you can see the same thing with all these multi-tenant applications out there in the cloud, we baked the idea of the tenant deeply into the architecture of our application. So the tenant is one of the most important constructs in our data access layer. Everything is always concentrated on the tenant. And when we do code reviews, this is something that we really focus on, that it never happens that a tenant 1 can access data of tenant 2. This is really very important to have it on a very low level in your infrastructure. Here you, for instance, see we use, for instance, XML as a kind of description language. In fact, we use XAML to implement this kind of domain-specific data model, and just some ideas. So we have a description, a declarative language to describe the domain-specific model of the tenant database. So we don't use direct SQL. And what this should make very clear is that someone who wants to change the database on an API level don't have to be able to write, create table or alter table statement. They just need to be able to handle either scripts or XML code. And take a look at, for instance, this one. We just say validation rule, and here we have a kind of Excel-like formula language in this area. We invented, no, we didn't invent it, but we implemented a kind of Excel-like formula language where we think that our end customers are capable of dealing with this kind of language. And this validation rule is inside the model. It's not something that is baked into the database as a kind of trigger. We don't implement it in C#. If you want to change the validation rule, you don't have to start Visual Studio and compile a DLL and put the DLL into a directory. No, you just go into this one, you copy this, you change this Excel-like formula, for instance, and you get immediately this validation rule for any kind of insert, update, delete method, for the WPF offline enabled client, for the browser-based client. We are capable of translating this stuff into expression trees and execute it in the MVVM model of WPF and on Silverlight. We have an experimental build where we can translate this stuff into JavaScript for a web-based client running in Windows Azure websites. The idea that let's go. Don't take a look at the very details. Get the idea here. What we did, we said we want to be extensible. What are the end users, the partners, the power users capable of handling? And developing a C# module was not the right way. So we made a decision to make a declarative language that we think that our power users are able to handle. And from this stuff, we can generate the database structure, we generate code, we generate HTML and JavaScript, and things like that. Do you get the picture? You get the idea? Question?
Is that something your tenant can do only once, or can it change and evolve during time?
Thank you for this question. Can the tenant only do it once, for instance, when creating the tenant, or can he continuously change this model? I will answer this question in a few slides. The answer is yes, he can do it constantly, but how we do that, we'll see. I've told you that. I don't have to repeat that. Yeah, this is the answer. No, this is not the answer. This is a technical detail. Yes, if you develop against a model, against a data model that is not known during compile time, you have a big problem. You lose early binding, you lose IntelliSense, because our developers program against a partly unknown data model. For instance, we say part of the data model is fixed, and the end user can not change this part of the data model. He can add things, and you can change the things that he added. We have this kind of namespacing system here. But if you say, hey, the whole data model is unknown and configurable, well, you lose in C# IntelliSense, for instance. And in this area, we go for interfaces. So someone who is capable of writing C# can, on the one hand, write such an XML file, and if he is capable of running C#, he can additionally add or provide us with a kind of interface added through MEF, and then when he is in C#, he can access the declaratively defined data model through interfaces with IntelliSense and things like that. You see exactly the same concept with this new and, in my point of view, great language, TypeScript. TypeScript adds interfaces to dynamic and unknown data structures of JavaScript. You have a kind of JavaScript class that can be extended at runtime, but you can provide independently of that an interface, and suddenly you have all the beauty of early binding, IntelliSense, and all that stuff. This is exactly the same idea, but here implemented with C# interfaces. How do we, for instance, create the database from our XAML data model, for instance, and how do we create, let's say, SQL statements, select statements, insert statements, update statements, if the whole data model is unknown? Our answer is string templating. We use XAML, you have seen it, and from this XAML we create the create database statements and select statements, insert statements, and so on with T4, Microsoft T4 templating engine. Everyone familiar with that? At least a little bit. We take T4, generate SQL, fire that against SQL database, everything's fine. If you are not the kind of relational database guy as I am, and you are more into NoSQL, and you are fine with having NoSQL, then you don't have to care about that, because you are schemaless, and your data store is already schemaless. Well, SQL is not schemaless, and therefore you have to create the schema, and using templates is a great thing. We love that. How does that look like? For instance, I think I have an example. Yes, this is, for instance, one of our old templates. It's not T4. It's our old SQL generation engine. It's using string template from the Antler project. If you're interested, you find it in the slides. And what you see here, it's a kind of template. And one important thing, again, the tenant. We are using schemas to separate tenants inside a single database. Do you know what I mean with that? Yeah? If we get another 100 customers, we will add 100 schemas to a single SQL Azure database, theoretically. But yeah, conceptually we do that. So we add schemas and we do not add databases. Why do you think we do that?
Security? Because you're cheap.
Cheap. That's the point. Security is
enforcement of schema.
right. We create a database user and define access policies based on the schema. So security is solved by the database for us. But we charge €6 per user per month. And when we started this application, the smallest database that you could get was 1 gigabyte, and it cost €7. Very simple thing. This is a practical example of catching the long tail. If we want to catch the long tail and charge €6 for our smallest customer, one person, then we cannot spend €7 for the database, because we would lose money. And we are not Amazon with Kindle. We need to earn money for every single customer. And therefore we decided, hey, you know what, for the small customers, take a single database and put multiple tenants inside the database. Design the price tag first. First we decided how much, deciding the decision about the price was done before we had written the first line of C#, productive C# code. We didn't manage to reach our goal. We wanted to charge €5 per user per month. We didn't manage that. We came up with 6, but at least we decided we want to be with €6 and not €15. And this decision about the price tag influenced our infrastructure, for instance, with the decision of putting one tenant in a single schema and not giving every tenant a separate database.
Why did you change the engine in the end?
Pardon?
Why did you change the engine in the end? You moved away from string template and you went to T4.
Yes, because the code that string template generated was very slow, and the code that T4 generates is much better.
Which version of string template you're using at that time? I guess 2. Because 4 is faster than T4. So string template 4, the engine is faster than T4. So that's
We have not thrown away our old code, so we could go back.
that's usually tested because I use string template 4 to generate templates for SMS messages, context aware as well. So they have to populate, yeah, hello, Mr. whatever, then that gets populated by database in blah blah blah. But it's faster than T4, not that faster, but it's faster, especially when you have to do it recursively, because that's one-off basically. But if you have to do it recursively a lot, the string template it's way faster than T4. So
thank you for that.
give it a try now.
We will try.
It's faster than T4.
Our templates are quite complicated and large, because we are creating the whole SQL stuff with the link kind of query language on top. But we can give it a try because we still...
That's once, right? You do that once to generate it. So, yeah, maybe it's the recursive thing that makes it faster. I don't know.
I don't know. But yeah, this was the reason. It was just the reason of performance. Question?
If you're putting multiple tenants in a single database, aren't they competing for resources?
Yes, they are. Yes, they are. The answer is longer, but I want to answer it because it's an important thing. It's just our personal story. I don't know if it maps to your situation. At the very, very, very beginning, when we thought about what should our application look like, of course we came up with, hey, it should be a really cool web XO web application with a nice web API in the background and all the cool stuff. And then we sat down and said, okay, an important feature is offline capability. Offline is very important for us. So at that time, HTML5 and offline, I mean, it's still hard to do, if not impossible. We decided, no, we need a full client too. So when we said, okay, we need a full client, and we need a browser client, then we started to calculate how much money do we have. And we quickly found out that we cannot afford for version 1 to build an HTML JavaScript based web client that is as cool as we like it and build an offline capable full client. And then again, design the price tag first, because we started to think, you know what, if we build a full client, then our end users pay for the CPU power, because they run the service on their CPU in their laptop. That could maybe help us in reaching our €5 goal. So we decided something that was really a hard decision. It took us weeks of sleepless nights to come up with this decision. We decided to build TimeCockpit in version 1, full client only, have a SQL compact edition on the laptop, similar to Microsoft Outlook, and write a very, very powerful syncing mechanism based on sync framework and do syncing in the background. So in fact, version 1 was designed for very, very low operational costs in Windows Azure, because the only thing that we had to pay in Windows Azure was SQL Azure. We didn't run a single virtual machine for version 1. And you know what's expensive in Windows Azure, at least for our concept? The virtual machines, not the databases. The databases are nearly free. You can forget about these costs. So the answer is, do they compete for performance? Maybe, yes, a little bit, when during sync. It doesn't matter if they compete for resources, if sync takes, let's say, 15 seconds instead of 10. We don't care about that. And really, it saved our necks a few times, especially in the early days of Windows Azure, because we had outages of Windows Azure for an hour or two and no customer was calling us. You know why? Because we had a full client, it was offline enabled. Well, sync didn't work for another hour or so. No one recognized it. So what I want to tell you is, it maybe not fits to exactly your situation, but it should prove the point of
design the entire infrastructure and price tag first and then decide what you want to do. Today, we can afford to run a web client too. Today, we can afford to offer a second client and have a web API and run these servers, everything's fine. And today, we put less tenants into a single database so that the web client performs nice and smooth. So this is the answer to your question. Today, we optimize less to offer a better performance, but we are not a very, very young startup anymore. We are still a startup, but we are a more mature startup, and we know about our figures in our numbers. Does this answer your question? It was a long answer, but it's the truth.
If you really want to take the most out of SQL Azure without having to do this, or Windows Azure SQL database, as we call it now, what you can do is that if you have a monitoring way with all the different ways that Rainer said up to this point, you can just move the schema to another server at this point, because if the clients are competing on the database level, then SQL Azure cannot do anything, basically, because it's a hot node, and it's a hot node with 2 hot tenants for you. But using a schema approach, then and having monitoring capability, and using simple tools like DCP, for example, for SQL Server, then you can connect to SQL Azure and take the whole schema, move it to another database, and then effectively have 2 hot nodes, one for the previous schema, one for the new schema, the customer that you moved there. And then you can take advantage of SQL Azure, because if it's a hot node, it will handle it better than having a hot node that has 2 hot tenants for you as well. Because then they start competing, and a hot node is a hot node. If you don't do something, it's always a hot node, and there is nothing you can do. But using an approach with schemas and having something, other database or symbol monitoring that you do, you can move schemas, because moving a schema, it's basically easy. You dump the whole schema and you upload it somewhere else. And then you do like migration by yourself. Then again, you can use federations, but you have to design the whole thing with federations in mind at the beginning. So
yeah, federations has a few downsides. We can talk about that with.
I was just about to ask that question.
Yep.
Any mind on doing federation?
Yes, at the time when we developed this, federation wasn't there, but we took a close look on federations, and there are some things in federations that I don't like that much. Things like changing a schema in one tenant, you know.
Manageability is not.
Right, things like backup, a lot of question marks for me.
Yeah, same like with everything else in SQL Azure.
yeah, but backups, if you use the schemas, it's the same idea. It doesn't matter if you use federations or not. Federations is a different database, so you just connect to the different database, and you take the backup directly from there. Changing the schema, then you need a strategy as well.
Yeah.
That's true. You have to go to each one of the databases and change the schema manually. I mean, basically you have to do it. It's not changing it once and it changes for everybody. But then again, your application has the benefit of having a declarative model. So even if you don't change the schema to all of them, they can still work, even if you have federation. So one thing can solve the other, but
Another thing,
definitely need a strategy.
Another thing, to be honest, to be really honest, when we decided the application, we wanted this backdoor, and we wanted to have the possibility to move out of the cloud. Today, we are not offering our software on-premise. We are simply not offering it, but it's not a technical restriction. It's simply a marketing restriction for us. We decided not to support it. We're a team of 5+2 freelancers, and we are happy with it. We don't want to hire a lot of support stuff to maintain locally installed IISs at our customer site. No, we don't do that. We love the cloud, but at that time, we didn't want to use any feature that is not available on-premise, and federations is not available on-premise. Of course, we could do it with a little bit of math, but okay. Any other question currently? So just another example here. I get asked this over and over again. Hey, are you crazy? You built your own ORM? You built your own data access layer because you don't use any framework, but you use your own T4 templates to generate SQL? Well, no, we didn't invent an object relational mapper because our data layer is not object oriented. And I'm a strong believer of duck typing and scripting. Customizations for our partners in our own tool, Time Cockpit, is done using Python. We love Python because Python is so nicely integrated in .NET. Would I do it again today in Python? Well, I'm not sure. Maybe I would bet the farm on JavaScript and not on Python, but I love scripting languages. And well, and what is the whole thing of Entity Framework? The whole thing of Entity Framework is code generation. Generating code so that you get IntelliSense. That's the whole idea of Entity Framework. But how should you generate code during compile and development time if you program against a partly unknown data model? It simply doesn't work. And therefore we needed something else. And therefore we built our own data access layer, which is very, very domain specific in this area. If you don't need that's the most important sentence of this slide. If you don't need a customizable data model, don't do it. Go for Entity Framework, live happily forever after. Your life will be much easier than it is for us. You know, it sounds funny, but this is the thing where, as I told you, our competitors are kicking our asses. Their websites look cooler. They have more money for marketing. Why? Because they don't give a shit about this customization stuff and so on. And it's hard for us to compete with them because they are selling a less powerful product with more marketing dollars. And it's hard to compete. It's really hard to compete.
Changing the data model of Entity Framework is not enough.
Changing the meta model of Entity Framework. Well, my original design was, let's build a meta model. Let's generate from the meta model the Entity Framework, generate the DLL and things like that.
Yeah.
The problem is, in a shared infrastructure, if you have 1,000 tenants sitting on, let's say, 5 web servers, and you get requests and requests and requests, you could load the DLLs of the Entity Framework per tenant during runtime, execute it, but then you have to get rid of it again. And collectible assemblies were not available before .NET 4. They came with .NET 4. And still in .NET 4 it wouldn't be possible for us to use collectible assemblies. We would have to go into more details of why we need that.
Yeah, but you could have injected at, as you said, not really loaded at runtime, but injected when the pool comes up. So when the application pool was coming up for the web app or whatever it is, you can have injected the DLL that you generated there.
Yes, but every tenant has a different...
when the pool dies, if its tenant has a pool, when the pool dies, your thing goes away anyway.
This would have been possible that we, for instance, use...
I'm not judging your architecture, right? I was just discussing, trying to get a better feeling why you did those choices and why not something else.
Absolutely, and if we have enough time, we will get to a slide where you see that today I would maybe go a little bit different architecture and do the same thing that Microsoft does with mobile services and use, for instance, their pre-built tenant separation infrastructure, which is called Windows Azure Websites. What would be possible today is to give every single tenant a separate Windows Azure website, upload their dynamically generated DLL into this website, and use it as a kind of front door for letting them
basically an isolation layer between the
using Windows Azure website as a kind of sandboxing mechanism in a multi-tenant infrastructure. Well, that's the future. Windows Azure Websites is not there. As far as I know, you don't have any management API for creating Windows Azure websites.
You can create, but you cannot do the rest of the stuff yet.
Right, exactly. So in the future, let's say in 1 year, in 2 years, in 3 years, this would have been a very interesting solution. Yes, I absolutely agree with you. And we did prototypes where we tried this in IIS with creating application pools, but at the end, this was the second killer feature. If you use Entity Framework, what is your query language? Well, it's LINQ. And there are features in LINQ, or there are features that we really need for our domain that are not in LINQ. So what we would have had to create was at least our custom link provider And you know what? If we build a custom link provider, then it's not very hard. Then we don't need any framework really anymore. Because then we have our custom link provider that translates our custom abstract syntax tree into a link, entity framework compatible expression tree, and this would have been so hard that creating this stuff was easier. Okay. Next one. Next one. I have to go quickly over a few slides here. API, we thought a lot about the API. How should we make our API available to the end customers? One idea was, you know what, no API, we change the database on the fly, let them access the database directly. Works perfectly for reporting. Our customers love it because they can access the SQL database with their favorite report generator. And if they add a custom field, we change the database on the fly, it has a beautiful name, and they can access it with their favorite reporting generator. That's fine for reading, but not good for writing, because writing is complex. If you have sync in place, you need this versioning stuff and so on, so no writing in this area. We could generate code, and in a framework, ideal, yeah, we can do that. Declarative, we could give them some kind of declarative language, like the XAML language that I've shown you before, or we could give them a kind of key value pair model. You remember the good old days of data table and data reader and things like that? Well, yes, it exists, but we don't like it. And then we have the dynamic languages. And this is my favorite playground. If we have a dynamic data model, why not use languages that have a dynamic type system? And we decided to go for the DLR, for the dynamic language runtime. I'm not 100% sure anymore that it was the right direction, but at that time it was a perfect decision. So the best language on the DLR is Python, and therefore you customize our solution deeply using Python. We became Python experts and we love Python, but well, history turned out that there is another dynamic language that is more successful than Python, and it's called JavaScript. JavaScript there is no really good implementation on top of the DLR. If I would build everything from scratch today, I would possibly build the entire system based on some kind of JavaScript stuff. I would do nearly the same things, but I would possibly think about building it using JavaScript.
Have you looked at LUA?
And what?
LUA, have you looked at
yes, we took...
It's very JavaScript-y looking, and
it's from World of Warcraft, right?
Yes.
Yeah, right.
And it's used on, well, that's the biggest use of it.
Yeah,
so,
I know. Yeah. I have customers who took a look at it, who took a look at Python and took a look at Java and used it. We went for Python. Was just
it's again, that's personal experience because I'm using Lua on mine, so it's
I think you can reach great goals with both languages. Yeah. But today
Lua looks more like JavaScript than Python does in the eyes of non-developers. So it's slightly more easy to do things, and especially if you have things declared up front, they can just reuse them. I think easier than they do. To be honest, I don't have so many power users in the end. It's just there because that's how we did implementations for data input, because it has to be dynamic. But well,
I would say 3/4 of all our customers use some kind of scripting language to do any kind of data integration, third-party integration, process implementation, things like that. But this is really a feature that is one of the unique selling points that we have because it's so extensible. Our competitors don't have it.
In the end, I was using it more to do the things that they were supposed to be dynamic, like data input, than my primary users.
Yeah, you're right. It's very useful for our internal stuff too. But let me make this point very clear. If I had this speech, let's say a month ago, I would argue again and again and again that JavaScript is no solution for me. Why? Because We tried it, it doesn't work for us. We have parts of our application where we need strong typing, where we love strong typing, where we need IntelliSense and Java. Our team, it's not only true for us, we are not that productive in JavaScript than we are in C#. Today, 1 month later, I think that our future goes very strong in the direction of JavaScript. Why? Because of TypeScript. I'm a big fan of TypeScript because TypeScript makes JavaScript a productive tool for us. So let's see what happens. For us it was always important to have one programming language. Okay, with a little bit of scripting in Python, but one programming language where we can really be excellent in, and it was C#. We can use it on the server, we can use it in our offline WPF client, and we can use it in the web. We have a Silverlight-based web application. That was important. This was very important for us. Write code once. Our entire user interface is a single code, and we compile it to Silverlight and WPF. There is not a single line of code different between the Silverlight client and the WPF client. We could not afford building two different clients with the same feature set in two different languages. But in the future, I think with a language like TypeScript, I have the idea that we maybe would sometimes in the future move away from C# as being our primary cross-layered language to JavaScript on the server with Node.js, on the web client with JavaScript, and maybe on the full client with Windows Store apps too. So this might be something, if I would start from scratch, that I would really go deep into. And Windows Azure perfectly supports this. So now I have to choose a little bit what's important that I want to show you. Yep, this slide, I told you about it. This is an idea of tenant separation where I would say it would be nice it would have been nice to have it when we started. That means not only separating tenants by schemas or databases, but taking Azure websites as a tenant separation container. Because Windows Azure websites, as I told you, can be scaled down to costs of 0. If the tenant is not active, we have no costs. So it's easy to give every tenant a single Windows Azure website instance. And if someone, for instance, needs to run a script or web API or whatever, this someone can get this Windows Azure website and access the tenant. I don't think there is yet the final costing defined for Windows Azure website. I'm not sure. I think they have some ideas, but it's not. Maybe this whole concept can be thrown into the dustbin because of the cost aspect. I don't know it yet, but it would be a possible solution. Question?
This is mostly on, let's say, isolation on the front end. We are very heavily into worker roles and so on.
Yeah.
Where we allow customers to inject custom, even DLLs like plugins, execute custom workflows in a shared environment.
Yep.
And we find it very hard, and I see that Microsoft also finds it very hard to have like process isolation. We have separate app domains, but still you use the same resources.
App domain is not enough.
Yeah. Do you have a solution for that already, or no need yet?
When Steve Marks was still at Microsoft, I asked him how we should approach exactly that problem, and he told me, just don't do it. That was his answer. Whenever I'm in Redmond, whenever I get someone of the CLR team in my hands, I tell them, build a very strong sandboxing solution in .NET and give it to us. We need a sandboxing solution for process isolation. Windows Azure Websites is one possibility. It's a first step into this direction, but I feel your pain. I have the same pain too. I would love to have it, but I don't have it.
You need a custom virtualization layer. There is no other way to do it. Natively, there is no other way to do it. The only way to do it natively, if you want to interact in processes and whatever, we can have discussions. After that, I've worked in the past in application virtualization technologies, and there are a couple of things you can do that you need let's say you need to expose yourself too much to very clever people to find a way to circumvent it. So like 99.90, I don't know how many nines you want of the people that you're your customers, they're not that clever anyway and they don't care anyway. So you won't have problems like that. But if you don't have a custom virtualization layer, other application virtualization or server virtualization, there is no other way to do it. And as we're talking for processes, that's application virtualization. To have isolation at that level, you need a custom virtualization solution. AppV is one of them. It doesn't run on Windows Azure well, but yeah, it's the same idea. You need something for like AppV, and again, the only way to do it on processes is dynamic injection of assembly code. There is no other way to drop down to the level of the so-called ring 0, which is kernel coding, and do it at that level. There is no way to do it at ring 3, which is where we work with as users or whatever.
Yeah. I mean, Microsoft has just solved it for the client because Windows 8 Store apps are running in a kind of sandbox, but again, they built it deeply inside the kernel, and there is no.
It's a huge amount of that is based on AppV. So if you look at it, the way that deployment works and the way that the isolation works, it feels and it looks like AppV, and then you have Server V on Windows Server 2012 to do server isolation stuff. And then it's virtualization technology on the process level.
But you know what the nice thing is? Microsoft is best when they develop software for their own needs. And they have things like SharePoint, they have things like MS CRM, they have Navision, they have Acceptor, they have this problem on every of these applications. So I hope they will open this thing up for applications like us or yours.
There are third-party solutions like Xilocode, for example, that they do this along with bundling of .NET in the same process. So the same exec has bundled .NET in it, only the DLLs that are being used by your application, and it provides isolation on the process. So the process, whatever it's doing, it looks at virtual file system, it looks virtual resources, virtual memory, virtual CPU, but it's actually on the application level. But I haven't tested how that works with workflows and things like that. But I mean, the technology is there. It's just that somebody has to make it really available and affordable to the rest of the people. Because if you look at Xilocode, it costs a couple of €1,000 to actually buy the thing.
Yeah. But why do you think that Windows Azure website isn't a possible approach for you?
Just for typical things like startup tasks, like I don't know, virtual networking, how that will work out. A lot of these extensibility.
So
points.
details.
Yeah.
Yeah. It could maybe be the details that make you from using it. But the idea, the Windows Azure website.
I agree. It's a it's a web role that we use.
Right. Right.
Acting as a
So we have only a few minutes left, and there is one idea left that I really want to give you, and it's the last idea, and then we'll summarize and close. This is something that hit us hard. It brought us 6-month delay from our original launch plan. It was the entire system of versioning. We simply forgot thinking about it. Or we didn't think about it long and deeply enough because we thought, hey, versioning, no problem. Let's develop it in a few slides. In a classical 2-layer module, you have a database, you have a client, and you want to do updates. Well, update the database, update the client, they have to fit together, everything's fine. Maybe you have a kind of offline store, it's getting a little bit more tricky, but you can handle that. If it comes to the 3-tier model where you have website server in the middle, updating is a little bit more complex because you have the database version and it has to fit to the application version on the web server because it assumes some kind of fields are there and things like that. Then you have a kind of service version and the client has to be compatible with the service version. And then it's getting even more tricky if you have some kind of database here in the middle. But in a multi-tenant software as a service extensible infrastructure, it's really getting hard because you have a lot of tenants up there. You have databases. Every database has a separate schema. So this database schema for this tenant looks different than this database schema for this tenant, for instance. Then you have web servers, a lot of them, and you have a kind of load balancer in the middle. And you know what? We decided at a very early stage that we must not force our customers into new versions at a certain point in time. So then we come out with a new version of Time Cockpit and we say we roll that out today. And we have a customer that says, well, no, good idea. I have 100 consultants using your software, and they have to all go through a training before using the new software, and I, as the customer, want to say when I do the upgrade. So we have to support multiple versions at the same time. What does that mean? In our case, we have a full client. So the full client has to find some kind of, or Silverlight client has to find the right web API to talk to. This web API has to support different service versions. The service version has to fit to the database version of the specific tenant. So you have to have a routing service where the tenant identifies itself. Based on the tenant, you have to find the tenant database. You have to take a look at the database and say which version is compatible with this database. I mean, which web server version. Which service version does this web server offer, and which client assembly is compatible with this service version. And if it's not compatible, you have to tell the tenant, hey, you know what, you can start your software, you can sync or whatever. And it's becoming even more complex if you add the local data stores, because they have a data version too. And this is something where we completely forgot that we have to automate this thing completely. So what we have today is we have a fully automated build process. This build process writes the assemblies into a database, and the entire deployment stuff is done automatically. So when we say, okay, this is the build that we want to call, I don't know, 2.0, it's just a check in a user interface, and then a routing database in the background is updated, and if the user logs in, the routing database is checked, the assembly versions down here are checked, which kind of service URI should I connect to and all this stuff, and yeah, then everything else is done automatically. And updating is something that the end user can do himself. He starts the full client, he updates, an administrator updates indirectly or triggers the update of the tenant database. And with this, all the end users are informed that they need a new version. And again, the offline capabilities saved our necks, because in our case, if an admin says, I want to update the database, nothing bad happens, because all our users can continue working with their application, and they have time until the end of the month when the next invoices should go out, and everyone needs to synchronize his timesheets with the central server. And that's fine, because in our case, the full client is not only able as an admin to update the tenant database, but it's also able to update the offline database on the client, and then sync is fine again. So offline was one of the most clever decisions that we made when we went to the cloud. But don't underestimate the complexity of running a multi-tenant software as a service version where you offer multiple versions to multiple clients at the same time. This is again a strategic decision. If you say I am Facebook, and if I update for all my clients at the same night, fine, then you have to live with it.
That's what Microsoft does.
Yeah.
Office 365 is all or nothing.
Yes, but I can influence the point in time when I do the update. I can delay it up to X weeks. They ask me, we use BPOS, for instance, we use BPOS and updating.
Yes, that's the old thing, going from BPOS, BPOS to Office 365. But on Office 365,
yeah, you're right.
It's big. They say that's the release time. For SharePoint, it's going to be a 5-minute downtime when we upgrade metadatabases, blah blah blah. Yep. You're on the new version.
Even Windows Azure.
Sorry?
Even Windows Azure.
Yeah, SQL.
No, Windows Azure, you can choose the version of the operating system. So
I'm talking about the real management portal and stuff. You get everything like everybody else does. You get the new features.
Yeah, but that doesn't really affect your working whatever. If Office 365 changes completely on how it looks and how it feels, again, they will give you the option as they did with BPOS. But if it's like 5 new features or whatever, you just take it. There isn't anything you can do. It's just on your agreement. So.
Being a kind of ERP system that works in the heart of our customers. I mean, these guys live by selling their time, and if their timesheet system doesn't work, it's the same as if a production company cannot produce cars. So being that kind of...
That's an example for today.
Yeah, yes.
Okay.
Yeah, especially.
Oh yes, I'm in Belgium. Oh yeah.
And
Spain it would have been good, but
yeah, and it even makes it worse when you're living next to Germany. Sorry.
In Austria, we don't really have a lot of carbon. So, it's 9 o'clock and I was told that I have time until 9 o'clock, so we have to go for the conclusion. First conclusion. Cloud computing enables people. Yes, cloud computing is a tool for building multi-tenant software as a service applications that catch the long tail. And one final story here. A lot of people forget that. I'm sure that you all are aware of this fact. The cloud is leveling the playing field. As an MVP, I participate in a mentoring program that is called MVPs to MSPs, Microsoft Student Partners, and I'm a mentor for a group of people in India. Hey, these guys are hot. They are 21 years old, one of them, and it's their 4th startup they are founding with 21 years. They are in the BizSpark program. They use all this crazy stuff that we are also using, but their costs are there, and they are definitely able to catch the long tail because it's really leveling the playing field. It's not easy. The complexity is not software as a service. Complexity is not extensibility alone. Complexity comes from the combination of being multi-tenant, being software as a service, and being extensible, and running this stuff in the cloud. It's the combination of these 4 things. And last thing, have your business plan ready. Design the price tag first, and derive your application and web and cloud infrastructure architecture from your business plan. I know most of you are technicians. I'm from the bottom of my heart a developer and technician too. I hate when the business people come to me and tell me, give me your business plan for the next 5 years. I would rather sit down and write C# code, but in the end, it's true. Everything comes from the financing perspective, and you have to think about your marketing, your go-to-marketing, your partner strategy, your business plan before you decide about your architecture. And with that, thank you. Thank you very much. I hope it was an interesting evening, and we can start the discussion.
Questions, anyone? No?
great session.
Maybe quickly about, I'm not sure if you're also enabling a mobile client for cockpits, but you'll probably get asked soon, I guess. So how is mobile adding to the complexity of your whole solution?
Currently, we don't have a mobile client. Why don't we have a mobile client? Because we have limited budgets. That's all. We would like to have a mobile client. First, why don't we have a mobile client? The whole idea of Time Cockpit is that we automate the process of time tracking. So we have so-called signal trackers that run in the background, and at the end of the week, month, or day, they are telling me what I did, and from that I can derive my billable time so that I will not forget billable hour anymore. That's the whole story of Time Cockpit. So how can we do that on the phone? We tried it. The background processes on the phone are a pain in the ass. And this is the reason why we don't have a mobile client yet, because we have a lot of feature problems with today's phones. The technical stuff, it is not a problem. Now that we have a mobile client running in the browser, it is easy to reuse this web service interface from a mobile client perspective. Absolutely no problem. And I'm sure that we could reuse a lot of the C# code that we have for Silverlight, for instance, and either use it directly or doing some kind of redevelopment. I'm not afraid of that part. So no, I'm currently not afraid of this stuff. But again, the value that a phone client, that a phone client could add to our software is currently limited.
Budget-wise, use the Indian kids you mentor. Budget-wise, use the Indian kids you mentor, so they can do it.
No, we don't go for this. Because of developer productivity, our mantra currently is keep all developers in one room. That reduces management overhead a lot. But yeah, we are not ready for running a distributed development team.
Yeah.
Yep.
How do you run backups? Do you run backups on your SQL?
No, Microsoft cares for disaster recovery. I heard. Yes, of course we run backups. Microsoft cares, in fact, for backups, but only for disaster recovery purposes. How do you do backups? You can get the slides, and you will find something like this. In fact, it's the export functionality of SQL Azure. So we create a transactionally consistent backup every day of our whole databases, and then we use the DAG packs to export the data. And there is a nice parameter for this exe here, where you can pass an XML file that restricts the tables that are exported to the DAG pack, and with this you can, for instance, create a DAG pack file for each tenant. And if the tenant calls you and says, hey, I had a problem yesterday, please restore my data, I have a DAG pack file that I can send him or that I can restore. So although we have multiple tenants in a single database, we could restore a single tenant, but to be honest, in our end-user license agreements, we tell the end users we are not creating backups. This is a safety mechanism because we know people will screw up and we want to be able to help them. But we don't guarantee it yet. Because we are offline, so people can take a backup of the SQL compact database and they have a backup themselves. Yep.
We are at this point in time, building out our own disaster recovery procedure just because we have been out on 2 days because we were just in the wrong data center for that time. Do you have any specific things? I saw something like traffic manager. I see, I don't know, maybe data sync to another database center. Did you build something like that, or is it something that you don't need at this point in time?
No, we don't need it because, again, our full client that is fully offline enabled saves our necks here. If our database is down for 2 days, if it's the end of the month, a lot of people will shout at us, but they can still work. Maybe not that fast, because some back office procedures run faster in the cloud than on their local machines, but they can work. No, we are currently not using that. Of course, we played with Traffic Manager and we have tried it, but I'm not a big fan of SQL data sync. Why? They are messing around with my database. They are creating triggers and things like that in my database, and I hate them for that, and that's the reason why I don't use it.
Okay.
We used Microsoft Sync framework with a custom sync provider for the whole syncing. So it's the same backend, but it's not usable.
What do you find the most limiting part of Azure at this point for your solution?
What is the most limiting part of Azure for our solution? It used to be the complexity and the problems that we have with deployment of cloud services, launching new servers. But this is currently going completely away by moving to web deploy and Windows Azure websites for nearly all our web tier. So this used to be something that we don't like. Our experience is that 1 out of 10 cloud service package deployments simply fails without any reason. That's our experience over years. Deploying our web service interface takes, and I'm not lying, 45 minutes. No one can describe to me why. It's not that large. It takes 45 minutes, and that is excluding uploading the package. I didn't understand it. With web deploy, it takes seconds. So the second thing.
Did you try to instrument why it takes so long?
I sent the subscription IDs to the guys in Redmond, and
send me an email and I can give you a location where all the log files go into the instance, and you can see what is delaying.
Really? Sounds interesting.